start that recording. Okay. So welcome everyone. Thank you for joining us on this workshop for commercial battery storage to hopefully give you a little more knowledge about how the technology works, overcome some barriers in implementing it in your facilities, and focusing on finances as well. For context on why we're holding this workshop, this is actually funded through a subaward through the Department of Energy. So we were able to receive a subaward grant through our partner InfraEnergy, basically to help promote education on green technology. So the reason that we're doing this particular workshop is that we issued a survey back in fall, which tried to identify, what are out of the green technologies out there, solar, battery, alternative transfer, EV charging, what were the biggest challenges or, things that people didn't feel comfortable with. And battery storage emerged as the #1 topic in terms of a technology people weren't very familiar with. They were also very concerned about the financing options in terms of the upfront costs. How do you do this at your facility? So in response to that, we've basically are doing these 2 workshops. This is focused on commercial battery storage, but we also have a residential battery storage workshop that we'll be holding in another month or so. But hopefully you're in the right place. So if you're interested in learning more about commercial battery storage, we are going to hopefully help you with that today. So to get started, I wanted to introduce you to myself as well as the presenter team here. So for those of you who don't know me, my name is Ellie Perry. I'm the Sustainability Director at Cal State Dominguez Hills. And with me today, I have a great technical team of presenters who are going to be covering the different aspects of battery storage. So with that, I guess, Uche, if you want to introduce yourself.
Hi, everyone. My name is Uche Isyugo, CEO, co-founder of InfraEnergy. We're focused on distributed solar and battery storage, as well as the software that powers and optimizes them. And it's a pleasure to be working with CSVDH and speaking today. Thanks, everyone.
Hi, my name is Kenny Seaton. I'm the Director of Central Plant Operations and Strategic Energy Projects here at Cal State University Dominguez Hills. We've experimented with batteries and solar quite a lot. Thank you.
Hello, Traeger Cotton. I'm with Southern California Edison, Senior Project Manager. I work with customers who are deploying distributed energy resources and have decarbonization goals. I know a little bit about transportation electrification and building electrification and sort of how all that fits together with our rates and incentive programs. Thanks.
And Andrew, if you also want to introduce yourself too, since you'll be helping us with that last topic.
Sounds good. Thanks, Ellie. And hi, everybody. Andrew Dupe, Chief Product Officer at InfraEnergy. My role really is around helping us bring the products that we want to market that really help accelerate the transition to clean energy and ensure that our energy grid is pretty resilient and need efficient both for our grid operators and for our customers. So excited to sharing some of this conversation with you all as well.
Yeah, and thank you to all your presenters for the knowledge you're going to be sharing with us today. For everyone in the audience, this is actually today's agenda as well. So we'll be starting off in that order with an overview of battery storage and the technology behind it. Again, going into the case study at Cal State Dominguez Hills, going more specifically into utility programs in terms of and rate benefits for battery storage, and then a brief overview of additional financing resources outside the utility programs. And then basically all of that together will take about 45 minutes. Hopefully. And then so we'll be saving the last 15 minutes for a live feedback survey as well as a live Q&A for any questions that you have. Additionally, on that topic, if you do have any questions as we go along through the presentations, Zoom does have a live Q&A option for you. So you're more than welcome to type in those Q&As into the chat. And then we'll be able to address that at the end. And some of the presenters may be able to respond to you directly via that Q&A tool, as we go along. But in any case, if you can, plan on having your questions addressed live in the last 15 minutes or so, we look forward to sharing this information with you. So with that, we'll go ahead and get started. And as a reminder to the presenters, just tell me next on the slide and we'll progress you along. So with that, Uche.
Thanks, Ellie. So you can go to the next slide, please. Like I said earlier, InfraEnergy has been focused primarily on businesses who want to have lower cost energy with clean energy resources. And so we started focusing primarily on solar and storage, and all our projects have had storage where we have solar. And so we have been expanding our options essentially we're a one-stop shop at this point with the addition of our software. And our software essentially helps end users save money on their power bills. How do we do that? We look at the tariffs, we look at their consumption, and we help shift some of their consumption to better hours in the day that helps the grid and also helps their power bill. And so we're getting support from the Department of Energy. We have the Small Business Innovation Research Grant, which has really supported our platform to get expanded to where it is today. And part of our grant from the DOE is really to build out a multi-asset platform. We see a lot going on with EVs really expanding, and that causes some challenges on the grid. So we're essentially building out a multi-asset platform that can incorporate not just battery storage, solar, but also EV chargers, EVs, to ensure that all these devices are orchestrated and everyone saves money on their power bill. The utilities have a more stable grid, and everyone's essentially happy. So our platform is really here to help support the grid and support end users. But on top of that, a lot of virtual power plant programs are emerging, especially in California. And so there is opportunity to monetize spare capacity of one's assets in the market. And so that's part of what our DOE grant is focused on. We can go to the next slide, Ellie. So battery storage is a very interesting technology, and battery storage emerged because of the fundamental problem being that electricity could not be stored. It had to be produced and consumed almost simultaneously. And so battery energy storage, obviously, is what enables storage of energy when it's produced, oftentimes in the daytime from solar, can be consumed at night with the battery. And so the first thing that an end user looks at is, well, what are my loads and what is the capacity that I require for my use? And so tailoring that battery storage size and also the solar size is very important. Looking at different technologies in the market, lithium ion has been probably the most prominent in the last few years. There are some other emerging technologies like longer duration, which have different economics. There's also sodium ion, which looks interesting. It's cheaper, but perhaps not as long lasting. And so lithium ion has been the most resilient, most economic solution by and large, and it's here to stay for a very long time. There are some other technologies that are emerging like hydrogen, but lithium ion is very important, and it's a very developed, mature technology. Costs have really dropped the last 10 years to where it's very economic. And in California, where there are issues where customers have high demand charges, extreme weather and fires where you can keep your lights on with a battery, that's proven to be a very resilient option and also cost effective. So one challenge though is integrating this technology with the grid, and the utilities have done a great job in bringing these resources together, orchestrating them while being integrated with the grid. So choosing the right battery for your business is very important, but the use case also really matters. Are you doing this because you want to have a resilience option? Are you doing this to shift your load? So it kind of depends on what you want to achieve with your solution. Go to the next slide, please. So how do you choose your battery option? Again, it depends on what your use case is. There are some very key parameters that you want to look at. And depending on your experience as a business with the technology, oftentimes we find that businesses have an RFP process and they have bids, and several companies bid for providing the solution, but then you might need to hire a consultant to help you understand what you're reading. And so part of what we're developing is a way for facility directors to make that decision and get the best solution for them. So some things are very key with a battery. If you look at your warranty, the number of cycles is often called out in the warranty. You can't cycle your battery more than X times. At some point, you void the warranty. And so battery cycles really means how many times you discharge and charge in a day. And if you do that multiple times, your battery wears and tears faster. the depth of discharge is essentially how wide you're charging and discharging. Kind of like your iPhone. Are you draining your battery from 100 to 0? Are you going from 80 to 20% before you charge? So that also drives your battery economics and longevity. But there is also an opportunity. So when you look at the cost of degradation and how much you're depreciating, you might be willing to do that because you see some upside in the market and you can export your energy back to the grid and make some money. And that economic analysis can be automatically done by tools, some of which we have incorporated and we're working on. So selecting your battery, again, is very important. There are many providers in the market. And so there's a trade-off between price and also functionality and longevity of the battery. Next slide. So what are some of the benefits? And I think we touched on this a little bit earlier. Cost savings. In California, we have peak demand charges. Part of our analysis as part of this grant has shown dramatic improvement in cost based on looking at peak demand. When you have peak demand on the grid and your peak consumption, that is up to 50% sometimes of your bill. And so consuming energy from your battery during those times of the day may really go a long way in helping you save money. Also, where there are extreme weather events or if there's a fire, which we don't pray for, having that resilience option is very key and could be very helpful. But what's becoming more interesting nowadays are virtual power plant programs. And so California has been very forward thinking in this, and this helps businesses and residential end users make money on their battery storage, but also on their other devices like heat pumps, where they could be on demand response programs. And so demand response programs have existed for a long time, but we're seeing richer programs that can drive better resilience on the grid and better power stability on site, and also earn more revenue for the end user. So we think it's a very interesting space that we're going to see a lot of progress on in the future. Next slide. So I mentioned virtual power plants earlier, and I'm going to hand it over to Andrew to talk through some of our work and some of what we're seeing in the market.
Thanks, Uche. And I know usually when people hear virtual power plant, it's not something that they're very familiar with because you don't think about power plants being virtual. So I think the first thing is really understanding what a virtual power plant is. Now, I think to start, we need to first explain what distributed energy resources are. So these are things that really suck up a lot of energy from the grid. Whether you're talking about you want to deploy a battery, or you have a heat pump, or an EV that's getting plugged in, or your HVAC, or any type of device that is taking up a lot of energy from the grid, and you have the ability to actually control what that resource is going to do, can effectively be considered as a distributed energy resource. Now, the thing here with these distributed energy resources is because they can put a lot of strain on the grid, they have the ability to put a strain in your pocket as well. So the whole objective of a virtual power plant really is to understand how these energy resources are actually impacting, both your actual bill and the grid, and orchestrating them in a way that it's minimizing the cost for you as well as the strain that you're putting on the grid. Now we can do that using something known as load shifting, where you're using the storage to reduce your peak demand charges, like which you mentioned, while at the same time giving you the potential to generate revenue by selling power back to the grid, and their actual interfaces where that work. And then you also have incentive integration, where maybe you have the storage sitting at your facility, whether it's a campus, a building, wherever it is, because utilities are incentivized to not have blackouts. They're incentivized to want more resiliency and stability. They're willing to actually either give you an incentive to change your behavior. Some of these things can show up in specific programs like demand response, and any incentive. There are other incentives as well, where these VPPs can actually participate. And we see that showing up in in markets that are really enabling solutions like virtual power plants. Now, if you go to the next slide, Ellie, I think what we've tried to do here is really provide what the view for this would look like. So here we just put a simple example, right? The picture on the right is just showing you have a battery, you have an EV, you have your building, you might have solar, and somehow we need to figure out how all these things work together to bring down your energy bill while supporting the grid. So from a grid operator perspective, there is a demand for flexibility, right? And from the virtual power plant perspective, you have the ability to supply that. So how do we, really manage this supply demand balance? When is really the best time to deploy? How do you think about the usage of not just the battery, but how maybe you're charging your EV or you're using power within the building? I know a lot of people today don't actually pay attention to exactly the most expensive hours and how much it's going to cost. And I'm definitely looking forward to, Kenny sharing some of the insights, because I know it's going to be, very clear that there is value in really orchestrating exactly how you're actually using these distributed energy resources. Because to the point which I made earlier, when you actually use these resources, influences the cost that you have to pay, especially when you're using energy during peak periods. So you have an incentive from a grid operator for demand flexibility, and the virtual power plant is able to supply that. But you also have energy exchanges, retail energy providers, and these are more people that are interested in hedging any exposure. And VPPs can also help them out as well. So, imagine a situation where a retail energy provider, maybe has committed to buying X amount of power, and they realize maybe a unit trips out or whatever happens and they don't have that availability anymore. They have the ability to tap into a virtual power plant platform like the one we're building, and they're able to really bridge that gap between the demand for energy and the supply of energy that they actually need. So virtual power plants really work by aggregating all these distributed energy resources and really controlling them to provide value to the grid, while giving the asset owners the opportunity to earn revenue. And if you go to the next slide, please, Ellie. So what we just wanted to put here really is, as you start to get deeper into this journey and start maybe talking to potential providers of distributed energy resources and virtual power plant solutions, there are a couple of things that really should be top of mind, right? One is really around understanding having a model that really understands what your demand profile looks like and the performance of these distributed energy resources. So to what Uche mentioned, some of the constraints around the battery can be, how often are you using it? The cycle count, the depth of discharge, as he mentioned, right? The actual energy you have available at your disposal. Your provider, from a virtual power plant perspective, really needs to understand what all these constraints are, both for the resources, but for the building as well. Now, they don't really need to do this. They also need to understand what is your actual use now, and what do they think your actual use is going to be, because that's going to be important. Where if, to the prior slide, where we're talking about maybe an energy exchange or a grid operator looking for flexibility, if they don't know how much flexibility you're going to have in the next 3 hours, 5 hours, 10 hours, it'll be very difficult to actually make an offer to generate that incremental revenue for you. So the first step really is understanding the demand profile of the building and any constraints around the distributed energy resources. And these constraints are applicable both for the battery, any EVs, the HVACs that you might be using, whatever distributed energy resource you have. And once you have that, the next step really is understanding how exactly is the energy priced. So this is where being able to map your energy use to what you're ultimately going to pay in your energy bill becomes important. That ensures that we're able to actually calculate the cost of energy at every interval of the day. So now you're able to combine, I know how much flexibility I have available, I know how much it's going to cost. So the next step is, to run the model and come up with what that optimal dispatch for the, distributed energy resources is going to be. Once you execute that, you need to settle the financial transaction that really says you've created this much value for the grid. Here's the energy generated. Here's how much you get compensated. And if it sounds like it's a lot of work, that's because it is. And that's why, we're investing really hard to, scale up our software and start to provide this service so that we make it really seamless, where we automate a lot of the process, and you as an energy consumer or facilities director can really understand exactly the value that these assets are going to create for you. Now, the last thing to just note here is, the revenue that you could potentially generate can range anywhere from what we've seen between 15% to 40% of the monthly costs being covered by, the participation of these virtual power plants. Now, obviously, that's not going to be for every month, right? You might have specific months where there are really, big strains on the grid. And in those intervals, or in those periods, you would see a lot more of an incentive from the market for either, frequency regulation type services on the grid, or just energy that's being provided. So the actual value that will be delivered from these distributed energy resources orchestrated within a virtual power plant can vary, but for sure, they have a lot of value that they can provide to you. And what we're seeing is really between that 15 to 40% range of your overall energy costs potentially being covered by the revenue you could generate. And that would really depend on your overall use and how the assets, are actually designed and the flexibility behind them. And that's pretty much it. You get all these things done and you're able to really execute here. So pass it back to you, Ellie. Thank you.
Thanks. And with that, we'll turn over to Kenny for a case study.
All right, thank you. Next slide. So I'm going to preface this by saying I'm going to try and probably go fast through this. So we got some time at the end for Q&A, but don't worry, the slides are going to be available to you, and I'm happy to talk later on if anybody wants more information. All right, there's a couple different styles of batteries out there if you've never seen them. If you've ever been to a Kaiser, you probably have seen a style like this. This is what we have at our campus. The footprint is 17 feet by 47 feet. If you're wondering, what's the footprint look like for different size batteries. This is 4 megawatt hours. We can do 1 megawatt for 4 hours. So half of this bank could do 1 megawatt for 2 hours. Next slide. This is another very common style that's taken over the market, is your trailer building, right? So everything's packed up into a shipping container. You'll have one of these, and you'll probably have a pad mounted transformer to get the power back into your grid. Next slide. What does 4 megawatt hours look like? So this is an actual historical trend data from my Christmas present a few years ago. This was December 26th. We got the notice to operate like on the 24th or something. We were running at 1.5 megawatts, turned on the battery, full blast at 1 megawatt, dropped down, ran from 4 o'clock until 8 o'clock, 4 hours. So that means when the battery was turned on, the whole campus was only using 500 kW. 1 megawatt is 1,000 kilowatts for those that to understand it a little bit better. Next slide. What does it look like on your bill? So here's a bill from 2017. Peak demand, Uche had said that it's, I believe he said 50%, it could be up to 50%. We're finding that it's 60% or more sometimes. The battery helps, so that's not as bad. So here's 2017. We peaked at 3.2 megawatts or 3,240 kilowatts. The price at that time for peak demand charges was $18.34. Of our $101,000 bill, $60,000 was for peak demand charges in 2017. Next slide. Here is 2019. In 2017, we had 1 peak demand charge. So it was the worst 15 minutes for the entire month. Didn't matter what time it happened. Then we increased that and we went to time of use peak demand charges. So now we have 1 peak demand charge that was $11.95 for the worst 15 minutes of the month during that day. And then we had an on peak. So that means from probably 4 to 9 or 5 to 8 back then, not sure. if you set a higher peak or whatever that peak was, you also got that at a different rate. And so you were paying twice. One got lowered, but then you had two, so it equals out to this, to a high rate at the end. Next slide. 2001, facilities demand charges, $20. We peaked at 2.2, mid-peak, a little bit more. Next slide. Why is battery and solar important? Rates are not going down. So if you can get in with a good PPA or come up with the financing through some of these new creative financing things that where the state helps us or the federal helps us, it's probably going to pay for itself eventually. In 2011, when I first started working here at the campus, demand charges were $11.70. In February of this year, they were $22.58 for off-peak, $25.75 for on-peak. Really, it was like $3 more. You paid the $22.58, and then another $3 for that peak. But you can see that the prices have continuously gone up. You could probably expect a 10% increase every year moving forward until something drastic changes. Moving on. Here's what it looks like thinking about the peach color is the battery kicking on. So during this month, our peak was 2.62 megawatts. If we didn't have the battery, the peak would have been higher. Here is our, at this time it was 5 to 9. So you can see that the battery lowered us down more so that we could try and have a lower peak during our 5 to 9 period. The light green here is the battery charging back up because the battery doesn't, it's different systems will charge different ways. We've since changed that so that the battery can't charge until after 10 o'clock at night. But as long as it keeps your peak low, then it doesn't really care. You can see how next day, 6 a.m., we turned on our air handlers, chillers fired up, and the battery had to kick in again to try and hold us at that 2.6. Next slide. Here's a full year's worth of data in a sense. Peach color again is the batteries kicking in every day to try and hold our peak. We installed electric chillers in 2019 this year in April. You can see how our peak went up, but the battery still compensated. So at the end of the day, it was still saving us money. And then September was the summertime, right? More electric chillers were running, so our peak went up, drops back off. Next slide. So it's not just batteries, it's also what Uche talked about, solar also, right? So solar can help offset that. We're gonna go a little faster on this one, but this is just showing that solar on the rooftops can make the building load get below zero. If we added batteries to these buildings, we could then take these buildings offline. Depending on what size your load is and how big your campus is, my 4 megawatt hour battery cannot run my campus. So I need to do my own virtual power plant and install maybe 3 more smaller batteries at, let's say, 250 kW for 4 hours. If I did that at the building level, now I can take those buildings offline and still be able to teach classes or run my business on the critical buildings. Next slide. Energy efficiency is super important. If you start talking about battery and solar, you don't want to put more battery and solar. That's going to be a wasted asset later on. So this particular building, Welch Hall, we did lighting and occupancy-based controls and solar on the rooftop. And our peak demand now is lower than our lowest demand 3 years before. 2018 is the baseline, the red, 2022 is the blue. Next slide. Takeaways. You should do energy efficiency first, or don't oversize your battery and solar until you have an idea of where you're going to be, unless you can get really, really good free money. It partners well with solar. Large scale is good for peak demand and demand response. If you have more battery than you need, it's not the worst thing because you can start making money with that, using it for demand response opportunities and energy arbitrage stuff. Multiple smaller ones can be just as good for peak demand, but also give you resiliency to smaller buildings. the large one doesn't give me resiliency for my buildings unless we go through and do a complete restructure, revamp of the electrical circuits and put all the smart SEL switches where we could automatically turn off buildings and stuff. It gets very complicated. Next slide. That's it for me. Thank you.
Okay, thank you, Kenny. And now we're going to pass it off to Traeger from Southern California Edison to talk about utility financing programs.
Okay, thank you. I'm gonna do my best not to double up on the good points that were made by co-presenters here. So I put the slide together, just some quick information on BESS that I've learned over the years, and just you know, wanting to educate our customers on. So I'm not going to pick on all these, but I'll pick a couple out. So as Kenny just mentioned, the typical configuration does not provide backup power for emergencies. Okay, usually that comes at an additional cost with some additional equipment and additional complication with interconnection requests. But it is doable if the configuration is right, you know, as Kenny talked about. So wanted you to know that these systems, these do require an interconnection agreement from Edison or your utility. So you have to submit a request, and it's studied, and it may require upgrades. Okay, pushing on. The proposals I've seen lately from customers share with me, these systems are typically, there's typically a service contract that's proposed. You can buy these systems outright, but lately I've been seeing a service contract model for the financial arrangement. And then lastly, I'm just picking one from each column so we can go through this. The capacity degrades over time, all right, just like a car battery does. And you know, Uche mentioned the cycles, and that does affect these battery energy storage systems. So you know, it's not that at 10 years they fail, they just have less capacity, right? And so the useful life at some point is in question. Next slide, please. Okay, so again, don't want to double up on what others have said here, but you know, how these systems are used, you know, different categories are shown on the screen here. We talked about demand reduction. All right, we talked about demand response. Andrew talked about virtual power plants and how that could work with our demand response programs. So there is money to be had there. We talked about load shifting, resiliency. The two that we maybe didn't touch on that I'll touch on is utility grid services. So sometimes we will have a solicitation, a request for proposals for capacity or reduction in capacity to help the grid in certain isolated places. Okay, so you can find that on our procurement page, or your vendors typically know about that. When those come about. And again, they're real isolated to certain geographic regions. And then the last one I wanted to touch on is reduced carbon footprint. Okay, so in case you don't know, the intensity of the carbon in the generation mix increases as in the on-peak hours. Okay, let's say. So it roughly follows the trend for pricing, right? So if you're doing this load shifting strategy, then and you're reducing your on-peak kilowatt hour kW, you're also reducing carbon intensive power. That's what I'm trying to say here. So that's another strategy if you're trying to decarbonize. I wanted to mention that one. Okay, next slide. All right, so this is more where the rubber hits the road here. What you want to know about is incentive programs and rates. So NEM. All right, so to touch on NEM, this is kind of important. NEM recently changed, right? We went to NEM 3.0. It's solar billing plan is what we call it. With that change, energy exported to the grid from renewable resources like solar is valued less than it was in previous iterations, right? So I say this to say that batteries then become a little more important, right? Because if you can store that renewable energy in a battery and use it later when the pricing is higher, then your financial play is better. Okay. So that change occurred this last year. in April. So new systems then are in this new solar billing plan structure. Also, systems that are in place that have that are about to come up on their legacy period, which is typically 20 years, will be put on the new solar billing plan. So I say that to say that if you have systems that are going to be coming off of NEM onto solar billing plan, you may want to consider a battery. Okay. Next program, self-generation incentive program. All right, so SGIP has been around a long time. It was retooled years ago to incentivize batteries. There still is a limited amount of money in the program for commercial, non-residential, I should say. One category is still open, and that's the large battery storage category. And we're in step 5 of the incentives. There's like 1.75 million available, and the incentive is 25 cents per watt hour, $250 per kilowatt hour. So the way you can think of it is about 25% of the cost, round numbers. Okay, but that again, that's limited funding, right? So that 1.75 million goes pretty quick. The other incentive categories are waitlisted. Okay, on-bill financing. All right, so this is a good one, and can't promise anything, but efforts are underway to expand our we have an on-bill financing program now for energy efficiency. Okay, we're looking to expand that and have gotten approval to expand that, but the details are still being worked out. So what we're trying to include is transportation electrification, building electrification, energy storage projects, not photovoltaic, right? Not solar, but other technologies. And if approved, look for that later this year. So fingers crossed on that one. And on-bill financing is 0% interest loans where the repayment of the loan is embedded, baked into your bill. So it's another line item on your bill, your Edison bill. Okay, so very good money there. Loan, it is a loan, right? So you have to pay it back, but 0%, so it's good money. Okay, I did want to mention rate option E. Okay, so Kenny, I was glad you pulled up a bill to show it, and you had a couple different rate options in the different bills that you showed there. But I just want everybody to know that there's different rate options, right, for whatever category, whatever general service category rate you have, and some of those can be more beneficial or less beneficial to solar or a paired storage. You know, paired storage is solar and batteries together. So you would want to analyze, or you'd want your consultants to analyze, which is the most appropriate rate, or which is the rate that will save you the most with those technologies. So rate option E puts more emphasis on the cost of energy, and thereby typically being a better option when you have solar, because that's an energy product. So option D puts more emphasis on demand. So if your strategy is to reduce demand, that might be a better option for you. So I'm just saying that needs to be analyzed. And with that, I think I'll hand it. That's the end for me, and I'll hand it back over to Ellie.
Okay, thanks, Traeger. And I believe Uche and I will be covering this section. So Uche, if you want to kick us off.
Yeah, I'll be very brief. So when you look at financing, what really matters the most are some of these key items here. The investment tax credit is roughly 30%. It could be more. And think about that as an offset to your actual CapEx that you spend on solar and storage. With IRA being passed, now there's a better incentive. Now there are also adders. If you're in certain communities, you actually get more than 30%, even up to 50% tax credit. In some cases, a production tax credit might matter if you're producing a lot of electrons where you want to get paid back that way. And essentially, it's an offset to your cost for paying for the equipment. Modified accelerated cost recovery is essentially depreciation. And these are more so arcane financing that helps make the deal more economic. And so depreciation, not to go into the weeds, is what makes you lower your tax bill when you look at lowering your net income. And so when you look at institutional investors who finance large-scale solar, even residential solar owned by institutions, this matters a lot. And with IRA, a lot of these benefits can be passed to the end user. And so it simply makes solar and storage more economic and a better decision. Incentives and rebates, Traeger already mentioned several of them. And so depending on your utility, you can also access some more. And Traeger's already mentioned SGIP and some others. Next slide.
Yeah, and actually, before we leave the investment tax credit, because I know a lot of you calling in are from the California State University system or maybe other higher ed institutions that aren't usually eligible for any kind of tax benefit, right? They recently changed or added a rulemaking change to the IRA this last year, I believe, so that actually enables us as institutions to pass that tax benefit directly to our contractors. So if you're doing a massive project, you don't get to claim the tax credit, but you can give that directly to help pay for it when you have those contractors come in and install that technology. So that actually helps us in terms of the financing, right? If we're trying to pay for some of these technologies on our new construction. So just wanted to throw that out.
Absolutely. And from the federal government, there are several options. We have some key ones here. The EPA, Environmental Protection Agency, has a new greenhouse gas reduction fund. It's $27 million. It goes towards green energy infrastructure. And so that's a lot of that's being released this year in March. And that's going to pass through green banks nationwide and CDFIs, community development financial institutions that are rolling out these monies, these funds to fund solar and storage at a much cheaper interest rate. And so they're more zero down cost options because of all the volume of funding that's being rolled out. For folks in the more rural areas, USDA has some programs, including energy efficiency programs. And what you find is many of these programs not only fund solar, but would also fund energy efficiency, retrofits, weatherization of businesses and your homes. The last one I'll mention here is the LPO, which is the Loans Program Office out of the DOE. And this program is in place to fund very large scale infrastructure. And you would find in some cases the city government might have a program with the DOE where they're financing a lot of different infrastructure, and residents can opt into these programs, and the DOE gets that finance as a $100 million ticker size. And so this really helps lower the cost of adoption of infrastructure. Next slide.
And great. So I think since we ran that quick overview, we can start opening it up to Q&A. So I will go ahead and shut down the recording for storage on our YouTube channel. And so I will close that.